Hello, today we will discuss continuity equation. The continuity equation follows from the principle of conservation of mass. Consider a fixed volume V bounded by a closed surface S. The total mass contained within the control volume is integral over V rho dV. And so the rate of change of mass within the control volume is ddt of integral over V rho dV. Now let us try to understand mass flux through a surface. Consider a small surface element dA with outward unit normal n. The component of velocity normal to the surface will be v dot n. But here there is a sign convention. When n is the outward normal, it is considered as the positive normal. Now let us understand mass flux through a surface. In a time interval dt, fluid crossing the surface occupies a volume v dot n dt multiplied by dA. This is the volume of the cylinder because length of the cylinder is v dot n dt and cross section is dA. So mass crossing the surface will be volume multiplied by density, that will be rho v dot n dA dt. That means dm dt, that is the rate with respect to time, will be rho v dot n dA. When the mass flux is going outwards, then n is positive, and when we are considering mass flux from outside the volume towards inside the volume, then n will be negative. So here is our mass flux, rho v dot n dA, but we have to integrate this for the complete surface. When we integrate, we get surface integral rho v dot n dA. Now conservation of mass is saying the rate of change of mass within a control volume plus the net mass flux through the boundary, the total is 0. That is the conservation of mass. Then we get ddt of rho dV volume integral plus surface integral of rho v dot n dA equal to 0. This is the integral form of the continuity equation. Now we will try to get the differential form of the continuity equation. For that we have to apply divergence theorem here. In the second integral, we have to apply the divergence theorem. So if we apply divergence theorem rho v dot dA, it will be divergence of rho v dV. Then the conservation of mass equation now becomes volume integral del rho del t plus divergence of rho v dV equal to 0. Because this was a surface integral, the second term was a surface integral, but we have converted it to a volume integral. That means we have in bracket del rho del t plus divergence of rho v dV equal to 0. Then we get del rho del t plus divergence of rho v equal to 0. This is the differential form of continuity equation. Now for steady incompressible flow, let us try to understand what happens to the continuity equation when the flow is steady and when the flow is also incompressible. If the flow is steady, then del rho del t equal to 0. So continuity equation now becomes divergence of rho v equal to 0. Furthermore, it is an incompressible flow, then rho is constant. So rho goes out, rho multiplied by divergence of v equal to 0, or simply divergence of v equal to 0. This is the reduced version of the continuity equation when the flow is steady and the fluid is incompressible. So let us consider a stream tube. Stream tube is like this. A stream tube is a surface formed by a family of streamlines. So these are streamlines, and a family of streamlines, they construct a stream tube. So volume integral of divergence of V d omega is the differential volume element. Then apply the divergence theorem again, then we get surface integral of V dot dA equal to 0. Since there is no flow through the lateral surface of the stream tube, only the inlet and outlet surfaces contribute. Reduces to minus rho A1 V1 plus rho A2 V2 equal to 0. And so therefore, rho A1 V1 equal to rho A2 V2, or A1 V1 equal to A2 V2. This is a specialized form of the continuity equation, and many times we use this as the continuity equation, but we have to remember that this is for the steady and incompressible flow. So in summary, del rho del T plus divergence of rho B equal to 0, this is the general continuity equation. And for steady flow, this term goes away, so divergence of rho B equal to 0. And for incompressible flow, this rho goes outside, then we get divergence of V equal to 0. And then if we specialize to a stream tube, then we get A1 V1 equal to A2 V2, or AV equal to constant.